Welcome to Lecture 2, Part 1, Interrupts. Interrupts are a core source of information for the microcontroller unit's internal operations. The way it works is when an interrupt is called, an interrupt service routine, or ISR, is called. So what happens is during the main program execution, when an interrupt occurs, it will execute the interrupt service routine and return to where the main program was once the interrupt service routine is completed. So interrupts can be split into three separate types. You have global interrupts, external interrupts, and peripheral interrupts. So global interrupts control is usually set by the register associated with the status of the microcontroller unit. So for the AVI architecture, your global interrupt enable is set in the SREG register. However, for the PIC18, the GIE is controlled by the status register. So when an interrupt is called, the global interrupt pin is cleared, indicating to you that an interrupt has occurred. So peripheral interrupts are interrupts which peripheral modules can work with. So each peripheral module within your microcontroller unit will have the capability to interrupt your main program. So looking at the AVR architecture, you have your ADC module, your timer module, your capture compare PWM module, and your serial communication modules, just to name a few. So for example, in ADC, an interrupt can occur when conversion is completed. When the timer overflows, an interrupt can be called. Using the capture mode, when a signal is captured, you can signal an interrupt. And in serial communications, you can call an interrupt when a message is received or a message has completed its transmission. So each module will have their own peripheral interrupts to notify your core of an event occurrence. Different architectures or different microcontroller units will have their own way of using peripheral interrupts, so you should refer to the respective datasheet for each different chipset, as well as each separate module, since they inform you of their respective interrupt bit. External interrupts are the last type of interrupts available in microcontrollers. Most, if not all, microcontrollers will have the capability for external interrupts to change its program flow. So using your GPIOs, which are your simplest peripheral interfaces, you can link up external systems to provide a trigger for your microcontroller unit. Now there are other ways to communicate information through as well, such as serial communication, which can also trigger external interrupts from other systems. So let's look at an example of how you can use it to link other systems to your microcontroller unit. So using the external system on the right, it will trigger your microcontroller unit, which processes that external interrupt. So in the AVR, one of the external interrupts available is called int0 or interrupt 0. And then from there, within your program, you can actually configure it to actuate a signal for an actuator. So for example, let's look at a manufacturing line. When a part is done, a sensor will indicate or an external signal is sent from the sensor, so your microcontroller can move the conveyor belt to move the part down the production line. And a big attraction of using microcontroller units is that it is low cost, it is effective, and is reliable with a lot of capability. A big part of using interrupts or multiple interrupts in your microcontroller is managing the interrupts. So when an interrupt occurs, your global interrupt enable bit or GIE is cleared. Now this means that any other interrupts that occur whilst you are managing the first interrupt will not trigger until the GIE bit is reset. Now this is where clever code design comes into play. You're trying to avoid these race conditions where you have multiple interrupts occurring while you are handling a single interrupt. Another thing to consider is that interrupts are not meant for performing long and complex tasks. They are signals which indicate to you what is happening in your microcontroller. So they should be short interrupt service routines which only provide an indication for your main program to handle the operation itself. So let's look at the previous example of the manufacturing line. So we have two external interrupts that are being used. So our microcontroller is being linked to two other systems. We have two timers that are being used, and we have our ADC module, which is converting an IR sensor input. So int0 will tell you when a part is done, which is roughly every 2.5 seconds. int1 will tell you to stop moving the conveyor belt. So when a sensor is triggered, indicating that the part has reached the next station along the line. The two timers, so you have one which is comparing the duration between the external signals. So that is a quality assurance to ensure that your conveyor belt is performing at its nominal pace. And you have another timer that's being used every 2 seconds to record data for your data logging. And your IR sensor also reads how far the next object is from the drop bin. Now, this is because your sensor is linked to another system that deals with a pick and place motion. So you can notice how these systems can get quite complex. And when you have looking at one part of it, which is your microcontroller unit, prioritizing your interrupts is a big part of code design. So in this case, let's look at this case of the manufacturing line. What should be your priority? Have a think about that and take it to you in class, and we can shortly discuss this.